This lesson we are going to be learning about simplifying exponents that have negatives. So for what we're doing, we're going to see lots of different types of problems. The whole point of these problems is to have positive exponents. So you're going to be given a variety of problems that have negative exponents in them. Again, the point is to have positive exponents. So by the end of this lesson, you will be able to give me the simplified and or exact answer, which is evaluating, for these type of problems. If I have simple negative exponents such as this one, 6 to the negative fourth. If I have negative exponents with different bases, this base is 3, this base is 6, and they're different bases, so what do I do about that? Here, negative exponents with the same base, 6, 6, those are the same bases. And what about if I have multiple bases to simplify? That's what I'm considering complex. Okay, so again, the whole point of this lesson is to make positive exponents. So here is our order for our lesson. We are going to have a mini review of exponent rules. Then we're going to be looking at negative exponents and negative exponent rules. Simple negative exponents with unlike bases. Simple negative exponents with like bases. Simplifying complex exponents, and then any helpful hints that might help you, like a summation of some of the stuff that we would be learning in this lesson. All right, what you need to know before this is you need to be fluent in exponent rules. So that's what we're going to start off, a mini review of those exponent rules. All right, stuff that you should be familiar with before doing this. It's very important to be fluent in the exponent rules before we move on to simplifying exponents that have negatives in it. So part 1 is a mini review of exponents. So remember, if I have the same base and I'm multiplying, I can take that same base and add those exponents. So this would be 8 to the 14th power. When I'm dividing exponents with like bases, it's 11 and 11, that's my like base, then I can subtract. So I can say 7 minus 2. I can subtract these exponents. So that will get me 11 to the 5th power. So again, here's more multiplication just like number 1. And the base here is 8. Coincidentally, it could be 7, it could be 100, it could be 46. It does not matter. All right, but when I'm multiplying with the same base, I can add the exponent. So it's 5 plus negative 9. That's the same thing as 5 minus 9. So 8 to the negative 4th power. All right, this is the type of problem that we're going to be working with today with a negative exponent, because we don't want it as a negative. We want it simplified to have a positive exponent. Okay. And number 4, this is division, so I'm going to subtract, so negative 7 minus 2. All right, and that is going to be negative 9. So it's going to be 11 to the negative 9th power. Another example that has a negative exponent that we will not want. We would want to change these to make it positive. And that's what we're going to learn today. So that was your mini review of exponent rules. Okay, we just covered that. Now we're going to be looking at the negative exponent rule. Right? We're going to be talking about these negative exponents now for sure in this part. All right, what is a negative exponent? That is a very important question. All right, so let's think about this. If 10 squared means how many times you multiply by 10. For example, 10 squared equals 10 times 10. All right. So if 10 squared means how many times you multiply by 10, then 10 to the negative 2 means how many times you divide by 10. For example, if I have 10 to the negative 1, I have 1 and I'm dividing by 10. Now if I have 10 to the negative 2, I am dividing 2 times. For example, here's 1 time dividing by 10. Well, if I divide by 10 again, sorry, you couldn't see. So this represents 1/10. I'm dividing 10 one time. And then if I divide it a second time, I can write it like this. Well, this is the same thing as saying keep, change, flip. Remember, keep this one the same. Change the division to multiplication and flip that one. Whoa, this matches exactly right here. Okay, that's what that is. So when I have a positive exponent, I'm multiplying. If I have a negative, I'm really dividing. That's what's happening. So say if you don't want to look at it in terms of numbers, if you want to look at it in terms of variables. If b to the 4th means how many times you multiply the base b, the exponent number of times, so it'll be b times b times b times b, then b to the negative 4th means how many times you divide by b. So that would be like this. 1b, 1 over b, 1 over b, and 1 over b. Okay, that's what that really means. So here's another example with b to the negative 1st power. The answer would be 1 over b. Here, b to the negative 2nd power. You're dividing it 2 times, so it's 1 over b squared. So let's summarize this in a much easier way to think about it. Okay. So here's our rule here. Okay. If you have a negative exponent, you're going to flip it and change the sign to a positive. Again, you're going to flip it and change that sign to a positive. So let's look back over here. I had b to the negative 1. I like to think of this as a fraction. So you can think of it like this. Okay, because it doesn't change that value of b to the negative 1st power if it's over 1, because it will still be b to the negative 1st power. So what I'm going to do is I'm going to flip it. It was b to the negative 1st over 1. I'm going to flip it to be 1 over b, but I'm also going to change it. Once I flip it, I have to change it to a positive. So now it's 1 over b to the 1st, which is right here. B to the negative 1st, flip it, is now 1 over b to the 1st with a positive. Okay, same thing over here. It was a negative originally. When I flip it, it turns to positive. We want positive exponents. So I'm going to break this down into steps. So I have 5 to the negative 2nd power. Okay, that's the same thing as saying 1 over 5 squared. And if I were just simplifying it, this would be my answer. But if I asked you to evaluate it, then you would say, oh, 5 squared is 25, so this is 1 over 25. So that's when it looks like this. Okay, but what if it looks like this? Well, it's at the bottom, so move it to the top and make it positive. Well, anything that is over 1 is just whatever that numerator is. So you would keep it like that. That's simplified as 1 power. If I ask you to evaluate it, then you'll say the answer is 25. So think of it as a fraction. If it's negative, you flip it and change the negative to a positive after you flip it. So here I have 5 to the negative 2nd power. I can look at it as a fraction. Then I flip it and change that negative 2 to a positive. Here, this negative 2 is at the bottom, so I flip it and change that negative 2 to a positive 2. And there you go. We're going to be using this rule throughout this whole lesson. So let's go ahead and look at a couple of these. Actually, I'm going to circle a couple that we are going to do together, and then I will have you practice the rest. Okay. So for number 1, I have 4 to the negative 5th power. Think of it as a fraction. Okay, well, it's on top, it's a negative, so now it's going to go on bottom. So it'll be 1 over 4, but it's going to be a positive 5 now instead of a negative. There we go. Here, make it a fraction so it's easy to kind of visualize, and then flip it. So it'll be 1 over 7, but it's no longer negative because you flipped it, and it's going to be to the second. So 1 over 7 squared. Now number 7, it's 1 over 9 to the negative second. It was at the bottom, so I'm going to flip it and put it at the top. So it'll be 9 squared over 1, but anything over 1 is just that top number, so it's 9 squared. Okay, and it says to write as 1 power right now. We're not evaluating it. Otherwise, I would say this is 81, and this will be 1 over 49. All right, but that's not what we're doing right now. We're just simplifying it and writing it as 1 power. So go ahead and pause this and go ahead and try number 3, 4, 5, 6, and 8 on your own, and then come back to check your work. Go ahead and pause now. All right, so hopefully this is what you got for number 3. For number 4, hopefully you got this. For number 5, you should have gotten 6 to the first, under 1. For number 6, 1 over 3 to the third power. And for number 8, this should have just been 9 to the fourth power. All right, and let me break that down for you just in case. It should have been 9 to the fourth over 1, but anything over 1, we want it simplified, just turn it into 9 to the fourth. Okay. All right. So right now we just reviewed the main rule, the negative exponent rule. If there's a negative exponent, you are going to flip it and change the sign. All right. If there is not a negative exponent, you keep it where it is. All of these examples right here had a negative exponent because that's what we're practicing right now. But it does not mean that you flip every exponent. You only flip the exponents that have a negative exponent. All right, so we first started off with a mini review of exponent rules, and then we just learned about the negative exponent rule that's going to help us with the rest of these 3. So now we're going to move on to simple negative exponents with unlike bases. And then we'll move on to like bases. All right, so we already did one that looked like this. Simple, we did the simple negative exponent. So if I have a negative exponent, I can turn that into this. Okay, to simplify it. I flip it and turn the exponent to a positive number. Now we're moving on to this one. How do I simplify this when there's negative exponents and there's different bases? That's what's next. All right, so this says to simplify and evaluate. Okay, well, if I'm going to simplify and evaluate, there's a couple things that I need to keep in mind. Okay, well, there's different ways that you can do this. I'm going to teach it to you in 2 different ways right now, just to make it easy for you to pick which one you like. Okay, so actually I'm going to kind of split it down the middle like this. Ooh. And then show you 2 different ways for each. Okay, whatever makes the most sense for you, use that one. All right, so some people like to do this in sections, right, to simplify and evaluate. What I mean is, if I were to split this into fractions, other fractions, it would look like this. I would say 4 to the negative second over 1 times 1 over 3 squared. Whoa, how did we get that? Well, all I did was separate it. I said 4 to the negative second over 1, and then 1 over 3 squared. because if I multiply them and put them back, 4 to the negative second times 1 is just 4 to the negative second. 1 times 3 squared is just 3 squared. I get the same answer back. So I'm not really changing anything, just the format of it. Okay. So at this point I can say, okay, well, is this one going to stay or is it going to flip? Well, it's a negative exponent, so my answer is going to be at the bottom, and it's going to be positive once I flip it. Now here, is this going to stay or is it going to flip? Well, it's positive, so it's going to stay at the bottom. So I'm just going to write times 3 squared. And if there's nothing on top, it's a 1. So right now, this is my simplified answer. Okay, 1 over 4 squared times 3 squared. Okay, I just simplified. Well, I'm going to wait to evaluate until after I show you the second way of doing this. So I'm going to rewrite this, 4 to the negative second over 3 squared. This is what I do. I think about it. I look at each one. Okay, I'm going to look at the top. I'm going to make my fraction bar. I'm going to look at the top. Is it going to stay there? It stays if it's positive. It flips if it's a negative exponent. So is this a positive exponent or a negative? Negative. So it's going to flip. It was on top. Now it's going to go on bottom and be a positive. Then I look at this one. Oh, okay. Is this one a positive exponent or a negative? It's positive. So it's going to stay. So I'm just going to multiply it like that. And if there's nothing left, I just put a 1. I have the same exact answer. So whichever one is easiest for you to say or do, use that method. Okay, so right now all we did was simplify, but I also need to evaluate, so I'll evaluate it just one time because I showed you 2 different ways to simplify. This is the same thing as saying 1 over 4 squared is 16 times 3 squared, which is 9. All right, and when I multiply those out, I should get 1 over, you should be doing 16 times 9, and 16 times 9 would be 144. So that would be your answer. Okay, so this right here is my simplification, and this is my evaluate. Okay, because it says simplify and evaluate. Now let's look at the next one. So if I were to split these up into 2 different fractions, this is 3 to the negative third over 1 times 1 over 2 to the second. Okay. Then I'm going to ask myself, what's happening? Is this going to flip or is it going to stay on the top? It is going to flip. So what I could do, if I didn't want to write it, go from here straight to here, I could say, okay, this is going to look like this. 1 over 3 cubed, because once I flip it, it turns into a positive, times, is this going to stay down here or is it going to flip? It's going to stay because it's a positive exponent. So then it looks like this. That is why I can multiply, because this is what's really happening. 1 times 1 is 1. 3 cubed times 2 squared looks like that. So here's my simplification right here. Right there. But if I were going to actually evaluate, it would be 1 over 27 times 4. Right? And 27 times 4 would be 108. So that's my evaluation right there. Okay, well, let's look at it if I didn't want to do it in fraction form. Okay, I'm going to ask myself, is this one going to stay on top or is it going to flip to the bottom? It's going to flip. Why is it going to flip? Because it has a negative, so it'll be 3 to the third down at the bottom, because once I flip it, I have to change the sign to a positive. Now look at this one. Is this going to stay on the bottom or is it going to flip to the top? It's going to stay. Why is it going to stay? Because it's a positive. So I'm just going to leave it at the bottom, and there's nothing left on top, so I'm just going to put 1. That matches that one exactly. All right, and that simplifies to be 1 over 108 as well. Okay, just like that one, because it's the same. I just showed you two different ways. This one is the more step-by-step version of this one. Okay, so I could have broken this one down to say 1 over 4 squared times 1 over 3 squared, and then that would have been my 1 times 1, which is 1, and then 4 squared times 3 squared. It's right there. Okay. All right, so pick whichever one is easiest for you. If you want to see the fractions, go for it. If you just want to think about, ask yourself for the numerator and the denominator, does it stay or does it flip, and then get to your answer, feel free, whichever one you're more comfortable with. So go ahead and try these two and see what you get. Try the fractions, try just looking at it, and then come back to check your work. Go ahead. All right, so let's look at this one. I'm just going to look at it and I'm going to ask myself, okay, is this going to flip or is it going to stay? It's going to stay because it is a positive exponent, so I'm going to write it on top. And I could leave room for the bottom one in case I need a flip, but if not, then it will stay on the bottom. So let's check. Is this one going to flip or is it going to stay on bottom? It's on the bottom now. Is it going to go to the top or is it going to stay on bottom? It's going to go to the top because it's a negative exponent. So it's to be 5 squared. Okay, well that's over 1. That's the same thing as just saying 2 to the third times 5 squared. This is my simplified answer, but it also says to evaluate. So 2 to the third is the same thing as 8 times 5 squared, which is 25, and that's equal to 200. Okay, I need to see your work for both if I'm asking for you to simplify and evaluate. All right, to get to this, you have to simplify in some way anyways. All right, here. I'm going to ask myself, okay, I'm going to look at the top one. Is this going to stay or is it going to flip? It's going to flip. It's going to go to the bottom. Remember, once it flips, you have to change the sign to a positive. The whole point of this lesson is to work with negative exponents, and the rule for negative exponents is if it's negative, you have to make it positive by flipping and changing the sign. Okay. Now for here, 5 to the negative second, is it going to stay on bottom or is it going to flip to the top? It's going to flip to the top. Okay, so here right now is my simplified answer, but I need to evaluate. So I'm going to say 25 over 16. How did I get 25? 5 squared is 25. How did I get 16? 4 squared is 16. You have to know your exponents. Okay, and this is an improper fraction, so when you divide it out, you'll get 1 and 9/16. This will be your evaluation. Okay. All right. Go ahead and try those two for practice. Go ahead, press pause. All right, for this one, I'm going to ask myself, does this stay on top or does it go to the bottom? It goes to the bottom, and I change the sign to a positive. This one stays because it's positive, and here is my simplification. Now, if I needed to evaluate it, it would be 49 times 64. All right, and when I do 49 times 64, it's going to be 1 over 3,136. Okay. If you want, I just started a kind of a pattern right now. I circled my simplified answer and I kind of boxed my my evaluation part. It's up to you. As long as if I'm asking for you to simplify and evaluate, distinctly show me which your answers for that. It'll help make it easier. All right, here is 2 squared. Is it going to stay or go on the bottom? It's going to stay because it doesn't flip. It's a positive exponent. Only negative exponents flip. Here It was at the bottom. It's going to flip to be at top and be positive. So right now, here is my, because it's really over 1, but anything over 1 is just that. So here's my simplification, but I'm going to have to multiply it out. Okay, so 64 times 4 is 256. Okay. All right. Let's just make sure. Okay. All right, last 4 for practice in this section. These are very common problems on benchmarks, so that's why I'm giving you lots of practice. We're on example 10 just for this section. So go ahead and pause and try those. And it just says simplify, so you don't have to worry about evaluating. Just simplify each of those. Okay, so go ahead and press pause and then come back. All right, so let's look at number 7. What I like to think of, if I see both of the exponents being negative, and remember, these all have different bases. Okay, all these bases are different. If they both have negatives, all I do is I just switch them and make them positive. I just flip both of them because that's really what you're going to be doing. And there we go. Here, if it's at the top, it's going to be at the bottom. So it's going to be 2 to the 4th times 8 to the 3rd. Here it's at the top. I know it's going to go on bottom. And then it's going to be 5 squared times 2 to the 1st over 1. Well, under 1, sorry. If you wanted, you also could have did 2 to the 1st times 5 squared. This will actually be the more proper way of writing it. All right, the smallest base comes first, but it does not matter. I'll accept both answers. And 5 squared stayed at the bottom because it's a positive exponent. Here, 2 to the 4th stayed at the bottom because it's a positive exponent. You only flip negative exponents. All right, here, it looks like 8 to the 3rd stays on top. And then this one is going to go to the top because I need to flip it. So it'll be times 3 squared. So here's my answer right here. Okay. And if you needed me to show a little more work for understanding, this is 8 to the 3rd. And then this goes on top over 1. And it's the same thing as saying 8 cubed. 8 to the 3rd is 8 cubed times 3 squared. And that's the same answer as that one. Okay. And if you wanted to write it more proper, you would write 3 squared times 8 cubed because 3 is a smaller base. All right, so hopefully that part makes sense. If not, go back and review this. All right, do the problems again. Take your time. All right, so when given problems like these, ask yourself, are they the same bases or are they different? Right now, we just dealt with this one. Okay, if they were different, make positive exponents if you have negative exponents by flipping. If it says right here, if there are negative exponents. If not, leave it alone. If they're different exponents, just leave them alone if they're positive exponents. It's already simplified. All right, so just to reiterate, if you have different bases and the exponents are positive, just leave it. It's already simplified. It's simplified. You only flip if you have a negative exponent. For instance, if I have 3 to the negative 2nd over 6 to the 5th. All right, we're trying to make sure we have positive exponents. In this case, these two exponents were already positive, so it's already simplified. They're different bases. I can't subtract these. I can't say 2 minus 5 because this is a 3 and this is a 6. The bases are different. For this one, I would have to flip because there's a negative exponent, all right? And if I ask you to evaluate, then evaluate. But if I don't ask you to evaluate, then just keep it simplified. All right. The next thing we are going to learn is what happens when they're the same bases. So what if I had 6 to the negative second over 6 to the third? What will we do there? That's what the next part is about. All right. And just a little pointer, sometimes on benchmarks, it may ask you to evaluate. And the only options, because usually on benchmarks it's multiple choice, if they ask you to evaluate, sometimes the only options are a simplified version. All right, just be familiar with simplifying to the end. When you simplify all the way to the end, that's when you evaluate, that's when you actually solve it. So just be aware that, again, the word evaluate and the word simplify are used interchangeably. So just see what you have, right? If it's multiple choice and you know it said evaluate and there's only simplified answers, pick the most simplified answer, because usually there could be several different types of simplified answers that aren't the actual real simplified version, meaning that there's another step you can do before getting to the last part, right before you evaluate. Okay, but don't worry about that for now. That's just like a little disclaimer that these two words are used in different ways. All right, so now we are at this one, part 4, simplifying negative exponents with like bases. We're almost done. All right, so we simplified this one already, simple negative exponents. That would be 1 over 6 to the 4th. We simplified this one where it would be 1 over 3 squared times 6 squared. Now we're going to be looking at this one when we have negative exponents with the same base. Okay. Unless I say to evaluate, which is to solve, just simplify the exponents to 1 power. Okay, that will help us a lot. All right, so negatives with the same bases. There's actually 2 ways that you could do this, all right, because we already learned the rules of exponents when it's the same base. When we're dividing, we could subtract the exponents, all right, but we also learned that if we see a negative, we can flip it. So I'm going to show you both ways just so that you know that you can pick whichever way you're most comfortable with. Okay, so for this one, it says flip first, then use rules. So flipping is making that negative go at the bottom. So it'll be 1 over 4 squared times 4 squared. All right, and then use rules. Rules means now I can add those exponents. So it'll be 1 over 4 to the 4th. Okay, perfect. I just did the first one. Now let's do number 2, using the rules, then flip if needed. Okay, so my rule says if I have 4 to the negative second over 4 squared, my rules say that if I'm dividing with the same base, I can subtract these. So it'll be 4, and then I have negative 2 minus 2, that's negative 4. Okay, so I use my rules, but then it's a negative exponent. Remember, I want positive exponent, so I would have to flip that, and I get the same answer. Sometimes when you're doing rule 1 or rule 2, you may, sometimes if you're doing rule, the first part or the first way or the second way, you may find that you may have to flip again or use the rule again, but that's okay. Okay. So you choose which one is better for you. All right, let's try number 2. Let's try both ways again. Okay, both ways again. I have the first way, flip first. Okay, so 6 to the 15th stays there, and this one goes to the top. All right, and then use rules, so it'll be 6 to the 18th power. Okay, now let's look at the second way. So I have 6 to the 15th over 6 to the negative third. So use rules, same base, so I can subtract those. So that will be 15 minus automatically because it's a division, it's a fraction, but then it's negative 3. Okay, don't say, oh, 15 minus 3 because there's a minus 3 there. No, that's where people get this part wrong. It's a negative 3, so it's 15 minus negative 3. And that turns into 15 plus 3. So that's 6 to the 18th. I get the same exact answer. So pick whichever method you like best. Okay, I'm going to show you both ways one more time for this one. Okay, for this page. All right, so flip first. That's the first way. Okay, well, remember they're both negative, so I could just flip both of them. But remember, once we flip it, we have to make it positive. Okay, and then use the rules. Okay, so 2 minus 8 is negative 6, but I'm going to have to flip again. All right, because it's a negative exponent, so I get 1 over 3 to the 6th. Okay. Now let's rewrite this problem and try the second way, just in case you like that one better. All right, so I'm going to use the rules. So I'm going to do negative 8 minus negative 2. That's negative 8 plus 2. That makes negative 6. Okay. Now I have to flip that and make it positive. Same exact answer. So you pick whichever way you like best. Okay, if you want to flip first and then use the rules, do that. If you want to use the rules and then flip, go ahead. Whichever way you like best. Okay, here we go. All right, so go ahead and try these 3 and then come back. Pick whichever one you want. Okay, go ahead and then pause and then come back. All right, let's look at number 4. The way that I'm going to do it is I am going to flip first. I like to flip and then use the rules. So I like to use the first way. Okay, so I have 11 to the 9th times 11 to the 14th. And then I add them together to the 23rd. Now this one, flip. So I get both of them are negative. So I'm going to do 7 squared over 7 to the 4th. All right, now I'm going to use my rules. So that's 7, and 2 minus 4 is negative 2. Ooh, I'm going to have to flip again. So 7 squared. Here, I'm going to flip first. That stays at the bottom. And then I have to simplify that. So that'll be 5. I can add those now. 5 to the 24th. This fraction looks a little weird. So I have that. Okay. All right. Looks good. Hopefully you got those answers. All right, so this slide again. All right, ask yourself, are they the same or different bases? If they're different, make sure you have positive exponents, and then you're done. If not, if you have negatives, then you have to flip. Now, if they're the same, you still need to make positive exponents, and you need to simplify it. But use rules or flip first. Up to you. Remember, you have 2 options. There's 2 ways to do it. You have lots of options here to choose what's best for you. All right, we're almost done. Okay, so now we are at this point simplifying complex exponents. You need to be familiar with all of this beforehand to understand this. Okay. So we're looking at this slide again. All right, if I want to make it a positive exponent, I flip it. Here, this will go at the bottom. Okay, and that's 1 over that. Here, it'll be, these are the same bases, so I can say 6 to the negative 4 minus 2, which is negative 6, which is 1 over 6 to the 6th power. Now we're going to be looking at this one when there's multiple bases going on. Here's my bases of 10, my bases of 8, and my bases of 2. All right, and these are the complex ones. And these are pretty fun. They look scary. They do, but they're not. All right, right here, this is just a little review of the types of problems we have seen so far leading up to these complex problems, right? Where we are adding these ones, it'll be 5 to the 14th. Here, we're saying we're subtracting those, so it'll be 4 to the 5th. Here, we're multiplying these, so it'll be 3 to the 15th. Here, we're finding like bases and then simplifying, and that will be 5 to the 4, 5, 6, 7, 8th power. Here, flipping this, 2 to the 2nd times 2 to the 3rd, combining those to be 2 to the 5th. Here, bringing this one down, this is very similar to that one, but it would be 1 over 5 squared times 9 cubed. Alright, these are types of problems that we've seen. This one we don't combine because they're different bases, so just leave it. Alright, remember, ask yourself, are they the same bases or are they different? If they're the same bases, then I have two different ways of going about it. Flip first, then do the rules, or do the rules and then flip first. And then if they're different, if they have positive exponents, just leave it. But if they're different and one's negative, flip it. Alright, now we're going to put it all together. Okay, so this may look scary, but it's not. Okay, we're going to combine all of the exponent laws to help simplify these. And what we're going to do is focus on them individually. Okay, for here, I can split this one up and say, oh, well, this is 2 to the negative 7th over 2 to the negative 5th. What is that going to look like? Well, okay, look, they're both negative, so I can flip them if I want to flip. All right, and they're the same base. All right, or I can use my rule to subtract them. That would be 2 to the negative 7th minus negative 5. That turns to a plus. That makes negative 2. And that really makes 1 over 2 squared. So all of this turns into this. Now let's see what happens for this one. Okay, well I have 3 negative 2 over 3 cubed. Okay, well I can subtract these, remember? So that'll be 3 and then negative 2 minus 3, that's negative 5. And that turns into 1 over 3 to the 5th. So right now I have this one and this one. But these dots mean multiplication. So all I'm going to do is say 1 over 2 squared times 1 over 3 to the 5th and put them together. Here is my final answer. Okay. So look at them individually. You're putting all of these rules together, figuring out which strategy you want to use to figure it out, and then having and give me the simplified version of this. Okay. Because right here I have a base of 2 on top and a base of 2 on bottom. Combine it so that it's only one base of 2. Okay, same thing for the 3's. So look at each base with its exponent separately. Okay, you can also think of it as if the exponent is positive, leave it where it is. If the exponent is negative, flip it. So let me show you what that part means. So I showed you with here by separating each one and then using the rules, but let me show you what I mean by this part, because this part's pretty cool. Usually after a couple of problems, that's when I teach that part. So I have 2 to the negative 7, and then times 3 to the negative 2. And then 2 to the negative 5th times 3 cubed. Okay, so what this part means is, this is what I do. Okay, is this positive or negative? It's negative, so it's going to go on the bottom and become positive. Here, is this positive or negative exponent? Negative, so it's going to go on the bottom. Okay, now look at this one. Is this one positive or negative? Negative, so it's going to go on top. Okay, is this positive or negative? Positive, so it's going to stay on bottom. And then at this point you have all positives, then you can start combining if needed. Okay, well 5 minus 7 is 5 minus 7 equals negative 2. So that's going to be 2 to the negative 2 times, this turns into 1 over 3 to the 5th because I can add those. Well, then remember that turns into 1 over 2 to the 4th. And if I'm multiplying it by this one, I can put these together and say 1 over 2 to the 4th times 3 to the 5th. All right? Oh, I don't know how I got 2 to the 4th. That should be 2 squared. Sorry. I multiplied that part. All right? And that will get you the same answer we got over here. 1 over 2 squared times 3 to the 5th. 1 over 2 squared times 3 to the... That looks like a decimal. That looks horrible. 1 over 2 squared times 3 to the 5th. Okay? It works. All right, so look at each base with its exponent separately. Combine bases so each base is simplified. Make sure all exponents are positive. So just make sure all exponents are positive. You can do it whichever way you want. Okay, so it says look at each base with its exponent separately. If the base is positive, leave it where it is. If the exponent is negative, flip it. Okay, so these are all positive. There's no negatives. So then let's look. Combine like bases so the bases are simplified. Okay, well I can combine those ones and combine those ones together. So this is going to turn into 2, and then 7 minus 2 is 5. Okay, times 5, 6 minus 4 equals 2. There we go. That one was pretty simple. I just simplified each one. Whatever works for you. And this one I didn't have to flip anything at all because they were all positive. Okay, now let's look at this one. I'm going to look at that one, and then I'm going to look at this one. Okay, here I have 4, and then 10 minus 5 is 5, times 3, and negative 8 minus 5 is negative 13. Negative 13. Okay, well, I can't put these together. I can't add those because these bases are different, but this is a negative exponent, so I'm going to move it to the bottom. And that's going to be 4 to the 5th over 3 to the 13th. There we go. So look at them separately, and that will help. Let's look at this one. Combine those, and then combine those. Okay, so it's going to be 6, and then negative 8 minus negative 2. That makes plus, so that makes negative 6. Negative 8 plus 2 is negative 6. Times 7, and this is 5 minus 9. That's negative 4. So negative 4. They're both negatives. Right now they're both over 1. So just flip it and make them positive. So knowing what I just did right now, I want you to do this problem again. And try it on your own without looking at your notes and see if you can do this problem again on your own. So go ahead and then pause and then come back. Alright, so hopefully you got the same answer. Alright, well, let me have you try this one. Instead of it being 2 separate ones, it's 3 separate ones. So go ahead and try and do whatever you want to do to solve that. Go ahead and then come back. All right, so this would be 10, and then it's 4 minus 8, which is negative 4. Okay, so I'm just going to keep it like that for now. And then times 8. So remember, it's negative. I'm going to have to flip it eventually. but it's easy to just do it all at once and not worry about simplifying one version and then combining it later. As you get more practice with this, you'll realize a method that's best for you. Okay, so I'm doing it in different ways just in case your brain is thinking that way. I want to make sure that I'm trying to help you out as much as I can because we're doing this pre-recorded. Okay, all right, so it's going to be 16 minus 22, and it's minus because it's all division. Okay, so 16 minus 22, that will make negative 6, okay, times 2, and this is 7 minus 3, which is 4. So this is what I have right now. 2 of these are negative, so that means it's going to have to go to the bottom, all right? And if I want to think of each one over 1, I can say, okay, well, this one is 1 over 10 to the 4th, times 1 over 8 to the 6th, because I flip it, times 2 to the 4th over 1. Now this is a perfect time to use the fractions here to help you understand this. If you don't want to use the fractions and you can get from here directly to the answer, which would be 2 to the 4th over 10 to the 4th times 8 to the 6th, then great, go from here straight to there, perfect. But if separating it into fractions, separating them individually, and then putting them together works best for you, go for it. Whichever way is better for you. You get the same answer if you're doing it correctly. Alright. Go ahead and try that one and then come back when you are done. Take your time. Alright, let's look at these individually. So here's the 9s. This one's by itself. And there's the 5s. Right? And I'm talking about the bases. The base of 5, the base of 2, and the base of 9. Alright, for this one, it's going to be 9 and then 4 minus negative 8. And that turns into a positive. So that should be 9 to the 12th. Times 2 to the negative 16th. I'm just going to leave it like that for now. Alright, because right now I'm just using my rules and then I'll flip after. It's up to you how you want to do it. Remember, there's lots of ways of doing it. It's hard for me to gauge which way you guys like best because I do not have you in a classroom right now. So I'm trying my best to pick different strategies to see what would help. Okay, alright, so then I have my base of 5 and it'll be 8 minus 10, which is negative 2. Okay, so this is what I have so far when I use my rules. Now I need a flip. Okay, well, I know this one's going to flip to the bottom, that one's going to flip, that one's going to stay. So if it's going to stay, it's going to stay on top. And if it's going to flip, it's going to go on the bottom. But remember, I have to make it a positive exponent. The whole goal is to have positive exponents that are simplified. Okay? Alright? And just in case you wanted to see it as fractions, it should look like this. So that this times 1 will be 9 to the 12th. 1 times 2 to the 16th times 5 squared will be 2 to the 16th times 5 squared at the bottom. Okay. Alright, so we've seen all of these types of problems so far, alright, throughout the lessons that we have had. Alright, today will involve these types, alright, some of these types. So hopefully you did well. Alright, so for this whole lesson today, we started off with a mini review of exponent rules. Then we looked at the negative exponent rule that helped us with the rest of these. Then we looked at simple negative exponents with unlike bases, negative exponents with like bases. Then we looked at some complex exponents where we looked at each base individually. So right now we are at helpful tips. Alright, so these are some helpful tips to help summarize some of the stuff to make it easy for you. Here, if it's at the top, it's a negative, so I can bring it to the bottom. Make it positive, then I can simplify to make that. If it is at the bottom, bring it to the top. So 2 to the negative third is now 2 to the third, and then you can simplify. If they're both negative, flip both of them. And it doesn't matter if they're the same base or if they're different. If they're both, oops, that should be a 2. If they're both negative exponents, flip them, all right? And then use your rules if you need to. Here I would need to use my rules because they're the same base. So it'll be 3 minus 2, which is just 1. So 2 to the first power. That's what that would be. Okay. All right, and what's the difference between evaluating versus writing in 1 power? All right, evaluating is solving. So if I have 5 to the third, which is 5 cubed, I need to solve it to make 125. So 5 times 5 times 5 equals 125. That is evaluating. If I'm writing it as 1 power, that means I'm combining bases that are the same to make it look like that. Or if there are bases that are not the same, like 2 to the 6 times 3 to the 5th. If I have this problem, that's simplified. I just leave it just like that. Alright, and sometimes you will get questions that use the word evaluate, simplify, and reduce, and it could basically mean all the same thing depending on who's asking. So just be aware of that. Those words are used interchangeably. Okay, and last thing about simplifying and evaluating, if I want you to write it as 1 power here, I can subtract those exponents, so that'll be negative 3. It'll be 1 over 3 cubed. That is writing it as 1 power. But if I were evaluating it, I would have to say 3 times 3 times 3 to make this. Okay, remember this is to evaluate, to solve. To simplify is to write it to 1 power. So an exponent to a base. 1 base. Alright, and that is the end. Thank you so much for the interpreter who was helping interpret this video. We really, really appreciate it. Thank you. And that was simplifying exponents with negatives.